Today, inshallah, we're going to continue or talk about the last part in our chapter. So we're still working on stoichiometry, the last section, which we talk about the limiting reactant and percentage yield. In the first part of the section, we already practiced how to determine the limiting reactant and the excess reactant in a certain reaction. Now we're going to practice on the percentage yield. Just to remind you, okay, or if anyone could remind me, what is the percentage yield? Okay, or what is the difference between actual yield and theoretical yield? Anyone can remind me, guys?
So can you say it again?
Yes. What difference between actual yield and theoretical yield?
Theoretical ال actual yield اللي هو it's not the full yield because
Yeah,
there's
that's not the full yield. That
loss.
means the actual yield which we get, or the actual amount of products we get of reaction. Okay,
For
that's
example, it's like
always
85%.
yeah, and that always is less than the theoretical yield, because theoretical yield that the amount or the products which we expect according to our calculations. But as usually, the actual yield not exactly like the theoretical yield. It could be the same, but actually not. We see that because of many reasons. Sometimes the reactants include impurities which prevent all the reactants to involve with the reaction. Some reactions are reversible, that means they work in two opposite directions. So like this, the reactants never will completely change into products. And also, we said maybe there is some gases or solids there, or they are escaped from the container which we already make the reaction in. So that's mean always we'll find that the amount of products which we get not actually or not exactly like what we calculated. So we call this person the actually. To get the percentage yield, very simple, as you can see the equation in front of you here. So the percentage yield simply is the actual yield, that means the real amount we get it, okay, divided by the theoretical yield, then multiply 100, okay. So let's practice here, guys. Today we're gonna practice how to calculate the percentage yield. So let's start by this one, problem H. He said chloropenzene C6H5Cl is used in the production of many important chemicals such as aspirin dyes and disinfectants. One industrial method of preparing chlorbenzene is to react benzene C6H6 with chlorine, as represented in the following chemical equation. You get the equation here. So he asks you, if you have 36.8 grams of C6H6, which is the benzene. So here this one is 36.8 gram. If you have these, okay, and that's react with the excess amount of chlorine, so we don't care about the amount of chlorine. So the actual yield, what actually gets is 38.8 grams. So what is the percentage yield? So what we should do in this case, guys? What do you think? What the first thing we should do? Yes, Hassan Rahim?
We will make 36.8 over 38.8.
No, of course.
Oh, I mean, we will minus
What
38
this?
minus 56.
No, 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 Hassan. Be careful. What this?
The actual yield.
So to get the percentage yield, we need to know the actual yield divided by.
Theoretical. Oh, we need
So
to
we
know the
must to
theoretical.
know what is the theoretical yield. We must predict how much this 36.8 is gonna produce from the chloropenzene. So how we're gonna solve this problem? Okay, first of all, we must use the equation. How many mole of benzene producing how many mole of chloropenzene?
Um, one produces one.
So 1 mole of benzene, C6H6, actually is going to produce 1 mole of C6H5Cl. So like this, we get the ratio in moles, but actually we are working in grams. So we
In
supposed
grams.
to convert this into gram, yes or no?
Grams.
So
Yes.
here, C6H6, it represents how many gram? So
Uh,
C6, that's, 6 multiply 12, because carbon equal 12, yes?
yes.
Plus how many?
Uh,
Okay.
6 multiplied 2.
6 multiply 1. Hydrogen is 1.
Oh, okay. 6
Okay.
multiplied.
So 6 multiply 2 multiply 12 plus 6 multiply, that's equal
78.
78. Good.
8.
Okay, gram. So 78, yep.
Why did we multiply it by 1?
Because the hydrogen, the weight of the atomic mass of the hydrogen is 1.
Ah, okay.
So here 6 multiply 12, because the atomic mass of carbon is 12. The atomic mass of hydrogen is 1, so 6 multiply 1. You get an idea?
Okay.
That's supposed to yield 2. Let's count this one, okay, here. So 6 multiply
multiply 12
plus
plus 5
5.
multiply 1.
Good. Plus
I don't know.
35.5.
Yeah. Okay.
So over Earth equals?
I will calculate.
Yeah, calculate.
It will be 112.
100. Please repeat
One
again.
second.
12 multiply 6, that's 72. 72 plus 5, so that's 79. 79, okay, plus 35.5. That equal?
112.5.
So 112.5. Okay, so suppose that 78 gram of benzene producing 112. So like this, we get the theoretical. Okay, so here we find if we have 36.8 gram of benzene, how much are they supposed to produce?
We'll make 112.5
Multiply.
multiply 36.8
Good, divided by 70
over 78
equals
53.07.
53.07. So like this, okay, that is the theoretical yield. That
No,
means
Mr. is 53.07.
0.7, no problem. So let's make it 53, no problem, okay? So like this here, 53 gram, that is the theoretical yield. That means suppose if I'm starting the reaction with 36.8 gram of benzene, that's gonna produce 53 gram of benzene chloride. But the actually what I get is 38.8. So let's find the percentage yield. So the percentage yield, okay, equal
38.8
38.8 divided by
over 53
multiply 100.
100.
Good. So it equals
73.2%.
73.2%. Okay, so that means you get 73% of the expected amount of benzene chloride in that reaction. Is it clear, guys?
Yes.
Is it clear for everyone, guys?
Yes, Mr.
Okay, so here, let's get another one. Okay, one more to ensure that it's easy for you. Okay, so here, let's find this one. He asks you, methane can be produced through the reaction of carbon monoxide and hydrogen in the presence of catalyst. Okay, so he provided the equation for you. Then he asks if 75 gram of carbon monoxide reacts to produce 68.4 gram of CH3OH. What is the percentage yield of CH3OH? Okay, so that's a very, very good question. Okay, so let's find here. He asks 75 grams of this is reacts to produce that. Okay, so what is the percentage yield? Okay, who can answer this, guys? Mariam, are you ready? Or just raising your hand from the previous question? Mariam?
Yes, Mr.
Are you ready for that question? Or just raising your hand from the last one?
Oh, no, the last question, sorry, I forgot.
Okay, so General Walid, are you ready?
Yes, Mr.
Yeah, so let's start to work. Okay, so first of all, what we're gonna do?
I have to get the theoretical yield.
So we must find the theoretical yield. So how much we have of carbon monoxide? That's 75 grams.
75 gram.
So regarding to the equation, how many mole of carbon monoxide?
1.
1 mole of carbon monoxide. Okay, that will produce how many mole of methanol? Okay,
One also.
So that will be 1 mole, sorry, of CH3OH. So let's count here. Suppose that 1 mole of carbon monoxide equal how many grams? So carbon is 12,
75.
oxygen is 16. No, we just took about
Okay.
the theoretical. So 12 plus 16, the equal
28.
28 gram. Good. So 28 gram. Suppose they are gonna produce. Let's count the methanol. Okay.
12
So 12. Good.
plus 3
3 multiply 1. That means 3. Good. Plus
plus 16
16. Good. Plus
plus
1. So overall they're gonna be
wait, 32.
32 gram. Good. So like this, okay, we're gonna find that 20 gram of carbon monoxide produces 32 gram. Okay. So if we have 75 gram, okay, of the carbon monoxide, so suppose they produce how much?
Okay, wait, Mr. He written 64, 68.4.
68.4. That what is produced from these. That the actual, or that's the actual yield. That's what you got. But we
Okay,
need to
so
calculate the theoretical one. So suppose that in normal situation, 28 gram produces 32. So if I'm starting by 75, I supposed to get how many?
85.7.
85.7 gram. Yes.
Yes,
Okay. So that's what should I get? You get idea?
yes.
Yes. So the actual
Okay.
amount which I get is,
68.4.
so like this, we could get the percentage yield. It's equal.
Yes, 68 point.
Yes.
Calculated.
Yep. 68.4. Okay. Divided by
68.
85.7. So it equals,
Multiply 100, it will
yeah.
be 79.8.
So it will
لا
equal again. Yeah. So it will equal
79.8.
79.8%. Okay. Is it hard like this? Is it hard, guys?
No.
No. Okay. So that's good. So let's pass to the second one here. Aluminum reacts with excess.
Sir, answer, I can't understand.
You can't understand. So let's work with me in this one. Okay. But actually, this one is okay. So again, let's see here. Look with me, Tadros. I'm gonna answer this question one more time. Question number 1. Okay. And then you are gonna work with me in question number 2. Okay.
Yes.
Here, Tadros, he asking you to find, okay, the percentage yield. We said that what is percentage yield? We said it is the percent, or that represent the actual amount of a product that we get over the theoretical one, the theoretical yield. What is theoretical yield? The expected yield based on calculations. So let's find how it works. First of all, regarding to the equation, we find that 1 mole of carbon monoxide, 1 mole of carbon monoxide, it produces how many mole of methanol?
3.
Where 3? Could you find here Aaron 3?
لا 1.
So 1. So it produced 1 mole of CH3OH. Okay, so then we need to work in grams, because we are just working in grams here. So we need to find the molar mass of carbon monoxide. Carbon mass is 12, oxygen is 16. Okay, so that means it's 28 gram. Yes.
Yes.
So let's find the molar mass of methanol. Carbon is 12. Then we have hydrogen is 1, so 3 multiply 1, it's 3. Oxygen is 16, and we have 1 extra hydrogen, that means 1. Is it clear till now?
Yes.
So that's equal 32 grams. So suppose theoretically that 28 grams of carbon monoxide produces 32 grams of methanol. So the amount which we start the reaction with, how much we start the reaction with?
75.
75 of carbon monoxide. So if I have 75 carbon dioxide,
تبقى
so
نعمل cross multiplication.
cross multiplication.
75
So
times
75
32
multiplied 32 divided by 28.
divide 28.
Could you calculate it, please?
Okay, 1 minute. So 75 times 32, 2400 divided by 28. 85.7.
85.7 gram. So that means regarding to this, if I'm starting the reaction by 75 gram of carbon monoxide, I supposed to get 85.7 gram of methanol, yes?
Yes.
But the actual amount that you get of methanol is
68.4.
So that means it's less than what I expect, yes?
Yes.
So I need to find how much this represent, or that's how much percentage is the result of that theoretical one. So we said that the percent yield, we're going to divide the actual yield, what actually you get, okay, which is 68.4 divided by the expectations, okay, 85.7. Good. Okay, so overall, multiply 100, of course, to get as a percent. So it equals
Yeah. Uh, 79.8.
79.8%. Okay, so that means you get actually 79.8% of your expectations. You get the idea?
Thank you.
Is it clear like this, Tadros?
Yes. Yes.
So could you please help me to answer the next one?
Okay.
So here it said that aluminum reacts with excess copper. So aluminum, we have excess copper. That means copper will not be just a part of our calculations. So copper 2 sulfate, according to the reaction given below, if you have 1.85 gram of aluminum, 1.85 of aluminum, okay. So and the percentage yield is, so he gave you already. Can you hear me like now? Okay, so again, from the beginning, he said that aluminum react with excess copper 2 sulfate. So excess copper 2 sulfate, that means this will not be used in the equation, they are not used in the calculations because it's already excess. We have a lot, so that is not the limiting factor. And then he asks you, okay, if you have just 1.85 gram of aluminum, okay, and the percentage yield already is 0.6, okay, percent. What is the mass of the copper is produced? How much copper is produced? Okay, so already he got the percentage yield. So in that case, I suppose to find the actual amount or the actual yield. Okay. Okay.
Okay.
So let's find here how we are going to work on this problem. Let's start to think. Yes, Tedros.
Okay. Well, 1.85 will
Yep.
produce
Yeah.
56.6.
No, of course, 56.6. It's a percent.
أيوة صح.
You start good. First, we must find the ratio between aluminum and
أيوة صح.
and copper.
to
So
equal
aluminum,
1.
suppose that 1 mole of aluminum produces how many mole of copper? 1 mole of copper.
1.
So the aluminum mass equal how much the aluminum mass is? It's 26, I think. Okay, yes, 26 gram. So that yields what is the mass of copper? Google it. Hurry up. Everyone, work with us. What is the mass of copper?
63.5.
Again?
63.5.
So 63.5 gram. So like this, suppose in normal situation that 26 gram of aluminum produces 63.59 gram of copper. So if you just have about 1.85 gram of aluminum, how much suppose they produce? Cross multiplication.
1.85 times
63.59.
4.5.
So it will produce 4.5 gram. That is the theoretical yield. Yes.
Yes.
So you have the theoretical yield, and do you have the percentage yield? Can you find the actual yield? Yes, simply because the rule states that the percentage yield equal the actual yield
divided
by theoretical yield. Okay. So here the percentage yield is 56.6 equals, so first that's multiply 100. Okay. So equals, what is the actual yield? That is the missed unknown divided by the real yield, which or the theoretical yield is 4.5 multiplied 100. So could you find the missing part, please?
Yeah.
Okay.
So we multiply 56.6 times 4.5.
Yes, then divide by 100.
2.547.
So 2.5. That is okay. The actual yield. So you're gonna just get 2.5 grams of copper if you start the reaction with 1.85 gram of aluminum. Is it clear here, guys?
Yes.
Is it clear for everyone? Guys, is it
Yes.
clear?
Yes.
So like this, okay, that's how we work on the problems of the percentage yield, okay? So like this, we finished the chapter of stoichiometry. It's a very, very important one. Actually consider one of the most important chapters about chemistry. So please study very well. And as I said, after our vacation, we're gonna have a quiz about that chapter. Suppose that you're gonna answer the section review as homework, and I'm gonna check it inshallah after the vacation. So any hard question, guys, here? Any hard question, guys?
No.
Thank you.
Okay, thank you, guys. Goodbye.